All right, this is module 21, perimeter and area of similar figures. If you remember from first semester geometry, there was an entire chapter that was associated with similarity, and we're going to actually be building upon that in this particular module. So we have theorem 11.7, areas of similar polygons. If you remember from that first semester module, or actually unit, it was talking about if you took corresponding, means similar position sides, those would be in ratio to one another. So if two polygons are similar with the lengths of the corresponding sides in the ratio of a to b, then the ratio of their areas is a squared to b squared. All you have to do is just square the actual amounts. So the side parts, side length of polygon 1 to side length of polygon 2 would just be, because it's a corresponding side length, a to b. So the areas, you don't have to actually figure out the areas and do a ratio and find out the ratio. All you have to do is just basically take this amount here and square the top and square the bottom. So it'd just be a squared to b squared. And remember, side parts, the corresponding side parts, that's going to be a to b. The perimeters are the exact same as well. If you figure out and you just add up all the side lengths and you reduce it, you'll still find that the perimeters is going to be a to b as well. So the areas is going to be a squared to b squared. And we're going to get to volumes in a later part of the unit. So we have example 1, find the ratio of similar polygons. Ratios of similar polygons. I tell you, first off, that triangle ABC is similar to triangle DEF. Remember that symbolism here, similar. It says find the indicated ratio. So I'm asked to find the ratio red to blue of the perimeters. So remember, if you remember from the previous part here, the perimeters is just going to be whatever one side length is to whatever another side length is. So in terms of the similar position parts, I know BC's similar position would be the same thing as EF's similar position, which they actually give, BC to EF. So I would actually have ratio of red to blue would just be 8 to 12. When you reduce it, divide by 2, you get 2 thirds. So divide each one of them by 4, and you get 2 over 3. What about the areas? So ratio of red to blue of the areas, you literally just take this amount here and square the top, square the bottom. So this would be 4 to 9 is the ratio of the areas. All right, so we have another example here. It says a large rectangular baking pan is 15 inches longer and 10 inches wide, or 15 inches long and 10 inches wide. A smaller pan is similar to the larger pan. So I tell you that it is actually similar. So that's kind of key and kind of tells you what to do. The area of the smaller pan is 96 square inches. Find the width of the smaller pan. So if I have these two here, I know I can actually figure out the area of the first one, 15 by 10, just by multiplying the two. So I multiply the two, I get 150 inches squared for the area. The other figure, they tell me that it's 96 inches squared, but that's all they tell me. So I know my length here is 15, my width here is 10. So what am I asked to find? I'm asked to actually find the width here, which you can call W, you can call X, it's completely up to you. But what I would do is I would actually find, I would do 10, because that's my corresponding side length, 10 is to W as 150 is to 96. So I have the areas over here, and I have the corresponding side lengths here. Now since I have the corresponding side lengths in this column and the areas here, what I have to do is I have to square the perimeter or the corresponding side lengths column to compare with the area. That was in the previous couple slides. That's what the theorem is basically stating. So what I would have is I would have 100 over w squared equals 150 over 96. And in this case, you would cross multiply and solve. Okay, so when I cross multiply and solve, this is the equation that I get. I'm going to divide by 150 on both sides. So I will get 64 equals w squared, and then square root, you get w is equal to 8. And since we have a length given, it'd be 8 inches. And that's it. So the main thing to take away from this is that if you have the corresponding side length ratio compared to the area ratio, you have to square the corresponding side length side of the ratio, of the proportion, to actually compare with the area. Okay, so example 2, we have you're installing the same carpet in a bedroom and den. The floors of the rooms are similar. The carpet for the bedroom costs $225. Carpet is sold by the square foot. How much does it cost to carpet the den? So in this case, we know we have the similar figure part here. These are similar. So we have 10 feet and 14 feet is the actual corresponding length. So 10 to 14, if I reduce that, I get 5 over 7. But in terms of comparing areas, because remember you have $225 to carpet the small bedroom, and you don't know how much it is to carpet the larger room, which is the den. So if we set these equal to each other, remember this is your area here, and this here would be your corresponding side lengths. You have to square your corresponding side lengths in order to compare. So this would be 25 over 49 equals 225 over x. So if you multiply these out, you should get x equals $441. Okay, so next practice problem is you have the perimeter of triangle ABC is 16 feet and its area is 64 feet. The perimeter of triangle DEF is 12 feet. Given triangle ABC is similar to triangle DEF, find the ratio of the areas of ABC to area DEF, and then find the area of triangle DEF. So we know we have our corresponding side length is 16 to triangle ABC, triangle DEF. And the reason I say corresponding side length is because remember, perimeters and corresponding side lengths in terms of a ratio are exactly the same. So if I were to reduce this, I would actually get 4 to 3, and then I'm trying to compare with 64 to x. Again, this is your area. Okay, so this is your area. This is your perimeter or your corresponding side length, perimeter or corresponding side length. And again, if you were comparing either area to perimeter or corresponding side length, you have to square each one of the numbers. So if you do that, you get 16 over 9 equals 64 over x. So when you cross multiply and solve, you should get x equals 36. You can put feet squared. Okay. So again, that kind of helps in terms of setting up a proportion using the ratio. Just remember, once you set up, if you have an area column or side of a proportion, like here, you have to make sure that the other one has the exact same units, so you have to square one of them. You could also take the square root, but that would actually make things a little bit more complicated.